Right, so welcome back. In the other video, we just talked about this question, all right, and then we said we wanted to solve this question using a t-test, independent, and a non-equal variance. Okay, right, so let's delve into that. Remember that in any hypothesis setting, you want to do any hypothesis test, the first thing you have to write is your hypothesis. So you have to write down your null hypothesis and your alternative hypothesis. So you have to write down the null hypothesis and an alternative hypothesis. So write down the null hypothesis now. Write down the null hypothesis and then the odds. Alright. So these are the two hypotheses you have to write, because these are the things that you, at the end of the day, you are going to either accept or reject or fail to reject. Okay, so these are the things you have to be key on them. All right, so in our case, we were asked to see whether the new method is better than the old method. Okay, so in statistics, what we do is that the null hypothesis is set out to show that there is no difference between the two methods. Okay, so we are saying that we want to test, so our null hypothesis will just say that the two methods are the same, their performances in the two methods are the same, the marks they got are the same, right? So invariably I can just say that the mean mark of the old method is the same as the mean mark for the new method. Okay, so somebody will also say that the old method is the same as the new method, the new method is the same as the old method, or the performance of trainees in the new method is the same as that of the old method. Okay, so which is, they are all just the same. All right, and then the alternative will just come in and then show difference. Okay, so if the alternative just shows difference, that the new method is different from the old method, that means we are kind of using this inequality sign. We are saying that the new method is different from the old method. We are not showing whether the new method is better than the old method or the old method is better than the new method. So in that case, where we are not showing the direction, which one is better than that, but we are just saying that they are not the same. In that sense, we are trying to do what we call a two-tailed test. A two-tailed tailed. It's like a tail of an animal. All right, a two-tailed test. This is what we are doing. But when we begin to show direction, so in our case, there is some direction. Is there evidence that the new method has led, on average, to higher scores? So here, there is that direction. We want to see whether the new method is better than the old method. So we say that the mean mark of the old method is less than the mean mark of the new method. So we are saying that we expect the new method to do better than the old method. So we've shown that direction. All right, so in that case, it's kind of saying we are using less than, isn't it? In that case, this is just a one-tailed test. A one-tailed test. So take note of the two-tailed and then the one-tailed. So when the question is there and you are reading, or you get a typical problem you are reading, you should be able to identify whether what you are doing is a two-tailed test or one-tailed test, because you will need that. All right. Alright, so when you are done with the hypothesis, the next thing you have to do is to find your test statistic. Alright, because out of your test statistic, you can get your p-value and come and compare your p-value with the level of significance given in the question and take your decision. Alright, so remember we said that we are dealing with unequal variance. So we have to be able to find a test statistic and the unequal variance. So this is the sample one, this is a data point. So we need some items from this data point. We need the mean, have to calculate. we need the variance we have to calculate, and we need the sample size. So the sample size, just how many are they? 1, 2, 3, 4, 5, 6. So you know how to calculate mean, just sum over n. Variance too can be done. So if you have a calculator, you can use that to find the mean and variance. You won't have any issue. Okay, so you would just have to calculate this element, this statistics from this is just a descriptive statistics. You can calculate that from these data points. All right, and then you can just look at the distribution. Okay, so this is a distribution for old training. Okay, so this is just a figure showing the distribution for the performance of those who went through the old training. Okay, and then this is the sample 2, which is the new training. We also need the mean, we need the variance, and we need the sample size. And this also is the shape of the distribution for those who went through the marks of those who went through the new training. Okay, so statistically what we are trying to see is that what we're trying to do in this test is to just compare these distributions. Okay, so let's put them together. What we are trying to see is that we are just comparing these distributions. So what our null hypothesis is saying is that we're trying to link this distribution and distribution. We are saying that they are the same. So our null hypothesis doesn't talk about it doesn't have any prior idea about them. It just assume that they are the same. Okay, so our alternative is saying that yes, this distribution, which is the old one, we expect it to be less than that of the new one in terms of, let's say, mean. So we believe that the mean of the new one is going to be greater than the mean of what? The old one, for the new method to be better than the old method. Listen, for the new method to be better than the old method, then on average, the new method has to have a very high average than that of the old method, isn't it? So you see that this part is depicting the direction. So that's where we are saying this is a one-tailed test. Okay, so statistically what we're trying to do here is that, see, looking at the shapes, can we say that they are the same, or can we say that the new method is better than the old method? Okay, that's what we are trying to do. We're just trying to compare these two distributions. We are trying to compare these two distributions. Okay, all right. So trying to compare these two distributions, and I'm saying that we are using the t distribution, and then we are doing unequal variance. Okay, so we have to calculate the test statistic, and this is the formula. The mean for the old one minus the mean for the new one over the variance of that, the square root of the variance, square root of variance of old method over number of items in the old method, plus that of the variance of the new method over the number of people in the new method, and then substituting the values we got there, we get negative 1.8356. okay, and then we have to calculate the degrees of freedom, right, which will help us to get our p-value. All right, and this is the formula. This is a formula that you have to know. So with this formula, substituting stuff inside, everything is there, gives you a degrees of freedom of 10.161, approximately 10. Okay, approximately 10. So now with the help of this test statistic and then these degrees of freedom, then we would go ahead and look for our p-value. So listen, finding the p-value, this is done by using the t distribution table, which I'll show you shortly, by considering the test statistic and then the degrees of freedom. So we'll find a p-value by just using the test statistic and then the degrees of freedom. So if the test we are doing is a two-tailed test, the obtained p-value is multiplied by 2. Otherwise, the obtained p-value is used to determine whether the hypothesis is to be rejected or not. All right, so remember that our example is just a typical one-tail test, so whatever we get is what we use. All right, so now let me show you the distribution table. So this is the T distribution table. All right, this is a T distribution table, and then you see that that's how we look like. Okay, so now our degrees of freedom from the question was approximately 10, and then our test statistic was negative 1.8356. So we'll throw the negative away and use the positive. So let's say 1.8356. So when you look at degrees of freedom of 10, we're trying to look for 1.8. So 1.812 up to, then this 1.948. So within this we'll have the 1.8356 in between this, right? So within this is where we are going to have that. In that case, we believe that the p-value is going to be between this. We believe that the p-value is going to be between 0.05 and then 0.04. Okay, so the fact that we don't know the exact value within that, where that we'll just try to use the average as an approximate value for the p-value. All right, so doing that, we believe that the p-value is between 0.05 and then 0.04. So taking an average of that is 0.045. Okay, so that's the p-value, and then the significance level is in the question. If not given, we assume that 5%. So the alpha value, if it is not given in any question, you assume that it's 5%. So our own was given 5%, so we use that 0.05. So now we want to take a decision. Now that we are done with the test, what do we do? Are we going to reject the null hypothesis, or we are going to fail to reject the null hypothesis? So now I said that when you have this type of test, the probability that the null hypothesis will be true is the p-value, and then the probability that the alternative hypothesis will be true is the alpha value. So compare these two probabilities. Which one has a higher probability? So if I have a higher probability of being true, then I'm definitely true, isn't it? If I have a lower probability of being true, then definitely I'm false. So when you compare this 0.045, that means that's the probability that the null hypothesis will be true, and the probability that the alternative hypothesis will be true is 0.05. That means the alternative hypothesis has some substance of being true. In that case, I'll reject the null hypothesis, isn't it? I reject the null hypothesis, and that when I do that, this is just statistics. So for me to communicate this to whoever is listening in need of that information, then I'll say that and conclude that the new method has led to an increase in scores, because this is what is in the alternative hypothesis. Right, so this is basically what you do when you get a typical T test, or you want to apply a typical T test in any of the fields you are or you find yourself in. Okay, so that is that. Make sure you give me thumbs up, subscribe to the channel, then make sure you just follow me and get the next video. We'll try to do this same test using a software, so that all this is a very tedious calculation, which you would not be using it in the field. In a field, you have to use softwares so that you move faster. All right, so that